All right, we are a few miles north of Preparation Canyon State Park on a piece of property here that you can see is much more hilly and is covered with Loess Hill prairie. We're going to take a look at some prairie plants now. This is a study site of mine this summer. I'm doing research here for the Iowa Natural Heritage Foundation. Looking at this, roughly this particular unit here is probably 100 acres or so of landscape that has a variety of different plant communities and ecosystems. We're going to look at the prairie here. This is a great example of Loess Hill prairie. And there's a wealth of species right here in front of us to start with. And so all around us you can see purple prairie clover. This plant here with the very tiny little compound leaflets. That's one leaf right there. Very, very small. You can see it there maybe now. And then these very distinctive purple flowers, kind of distinctive inflorescent structure there with a kind of a cone-shaped receptacle with a bunch of flowers coming off of it. You've got both of the real common prairie clovers here, purple prairie clover here again with the purple flowers, and over here is white prairie clover. As you can see, maybe white prairie clover tends to be a little bit larger plant. Very distinctive, no difference of course in the color of the flowers, but vegetatively there's a difference as well. And I'll try and show that to you here with a couple leaves. So I'm trying to put these leaves on my hand here so maybe you can see them. These are purple, the smaller ones with the smaller leaflets there are purple prairie clover. And then the leaflets with a little bit larger size, a little bit longer, a little bit broader. Kind of a relative thing. You kind of have to get used to seeing them and appreciate this difference there. But yeah, once you learn them pretty clearly, a larger leaflet, larger leaf in general on the white prairie clover. Both of them are, I think, a lot of ecologists kind of consider these to be ice cream plants. It's a term we use for plants that grazers really love to eat. Of course, the prairie clovers are in the legume family, the pea family, and fixed nitrogen, so they're important in the ecosystem for that. But also because of their nutrition, again, and their palatability, again, probably a real favorite plant for bison and elk historically to eat, but even cows. All right, then another legume, let's stick with legumes, if Pat can kind of just swing around a little bit. Another real common legume out here in the Loess Hill prairies, you can just see it just covering the landscape up ahead of us there, and also in all its full glory right now, lead plant. This is Amorpha canescens. The purple clovers were, the prairie clovers, excuse me, were Dahlia purpurea and Dahlia candida. This is Amorpha canescens. Again, it's going to have compound leaves like most plants in the legume family have, or at least many of them do. Lots and lots of leaflets on this compound leaf. Elongate inflorescence structures, again with very tiny flowers, kind of similar to the prairie clovers. The flowers are tiny. There's a large number of them that are arranged on these branches here. It's called lead plant for the leadish, sort of dull grayish look that you can see on the leaves. I think the old saying goes is that people thought that meant that maybe there were lead deposits around, but of course that has nothing to do with that at all. This dull grayish lead looking like coloration on the leaves or leaflets is due to the hairs, the pubescence that's covering these leaves. The leaflets are all covered with tiny little hairs, kind of white in coloration that give it that lead-like color. Well, let's see, then we can look at some other things that are vegetative here. I'm sure we'll see some better examples of this, but since we're right here, there's a single stem of a blazing star that's real common out here. This is dotted blazing star, and it's starting to form some inflorescences there, some flowers it looks like. It's blazing stars are generally a little bit later in the summer, at least the last half of the summer. Dotted blazing star is a great example of several species that occur out here in the Loess Hills that are really more western species in terms of their biogeography. If you were to look at a map that shows where the dotted blazing star lives in general, what its natural range is, it would be primarily to the west of us, out in the Great Plains. But many species like this and others that are, again, our western Great Plains species come into Iowa, make their furthest east presence, their most eastern portion of their range just comes into western Iowa here, maybe the western third of Iowa. And many of them are really common out here in the Loess Hills because, of course, the hills are a very dry type of prairie, very dry. Primarily because of the elevation change that we see here. Again, as Pat was panning in here, you can see the lower portions of this landscape, and then as we come up under this ridge, we're gaining in elevation, and that makes it much drier here because, of course, water is going to flow away from the surface here and make the soil much drier. All right, we've hiked up the ridge here a little ways, a little bit higher in the landscape to get a better view and see what else we can find. And here we found a green milkweed. This is Asclepias viridiflora. Green milkweed is one of the many species. There's about 17 species of milkweeds that we can find in Iowa. And this is one that occurs in somewhat drier soils. You can see the typical milkweed flower here, or at least the umbel, that the arrangement of the flowers. Green milkweed has this sort of greenish white corollas. The flower color is kind of a dull greenish white, so not very spectacular in that regard, but a really important species. Milkweeds are, of course. The leaves are somewhat broad here. Leaves can actually vary quite a bit in their size. This is a more broad version. You can also find green milkweed leaves that are probably about 1/4 or maybe 1/5 this size, so much more narrow. It's the same species, just individual variation that occurs in the size of the leaves. Many milkweeds, including green milkweed, are pretty sporadic. We don't see large numbers of stems in any one place. You'll just see sort of scattered plants as you move across the prairie. Right next to it here is a plant that is a really good indicator of the dryness, again, of the Loess Hill prairies out here. This is called skeleton plant. You see there's not much more to it than just stems and branches. There are tiny, tiny little remnants of leaves. I don't know if you can be able to see them, but just a little tiny little tissue, a bit of tissue along the stems here. They don't really amount to much, of course, those tiny little leaves, and so the plant accomplishes photosynthesis by just the chlorophyll that's in the branches and in the stem. Of course, this is an adaptation that plants use in general to cope with dry conditions and to conserve water. That's the paradigm, of course, that's the paradox, I should say, of plants, is that when they do photosynthesis, that means the stoma, the little pores on the leaves, those are going to be open to allow carbon dioxide to come in. At the same time that's happening, water vapor is going out. So anytime a plant wants to manufacture food, obtain some nourishment, it's going to lose water. And to help minimize that, plants will reduce the size of their leaves, because that will help minimize the amount of water loss. Well, skeleton plant here is just taking it up to pretty much an extreme, and pretty much has gotten to the point where it doesn't have any leaves at all. It does all the photosynthesis just in the stems and branches.
Tom, we've got something interesting here. What is this hole right here in the soil?
That's a good question. Well, it's a burrow, that's for sure. Certainly would not expect a crayfish way up here in this dry soil. It doesn't really look like that. Of course, they have a little mound associated with them, but it's about that size. Probably some small mammal.
Okay.
All right, if we just move a little bit this way, here is a great plant to find out in the Loess Hills. It's passiflora. So these are the leaves of passiflora, basal leaves that come from a clump, rise from a clump. Now passiflora is one of the earliest, or the earliest species to bloom out here, blooming usually by sometimes late March, early April. Has a great flower, of course a large buttercup type of flower. But it's way past its time for that. These look like they probably didn't flower because there's no sign of any fruits here. This site, by the way, was burned earlier this spring, and so that would tend to lessen the probability of finding some passifloras that were in flower or have flowered and have fruits. Let's do one more here. Let's do a grass. So yeah, let's click on a grass here, I guess. So there's lots of grasses here. All of these are going to be vegetative, of course, at this point. Most of these are all, in fact, pretty much everything I see here is going to be a warm season grass. Grass with C4 photosynthesis, what we call warm season. Again, a good adaptation for dealing with dry soils. The one I'm going to pick on right here is this one, because this again fits that description I was talking about with the dotted blazing star. This one is called Western wiregrass or Western muley grass, Muhlenbergia cuspidata. This again is more typically would find it in greater abundance and more commonly see it in the Great Plains to our west. It does occur in other places in Iowa to the east of the Loess Hills in really dry, gravelly, maybe morainal soils. Again, it has to be a soil that's going to be pretty dry, well drained, very porous. It's really common in the Loess Hills again because of the dryness of the soils here. So not only is the elevation, the steep slopes, which of course encourages movement of water away from the soil surface, good drainage or at least runoff. You also have the situation in the Loess Hills where there's lots of different aspects, lots of different slope directions because of the topography. And any of those slopes that are facing to the south or to the west, again, are going to be much drier because they get more direct exposure to the sun, more evaporation. And I mention that because, again, Western wiregrass is often a dominant species on some of those south and west facing slopes. Here is a plant that I consider to be maybe the hallmark plant of the Loess Hills. When you see this plant, it's easy to recognize. It tells you that for sure if you're in Iowa, you're standing in the Loess Hills. This is yucca, or Spanish bayonets, Yucca glauca. Very distinctive, of course, with the very narrow sword-shaped leaves, narrow leaves, fairly succulent leaves, little thread-like fibers that peel away from the edge of the margin of the leaves here. It produces a very large, very distinctive kind of cream yellow, pale cream yellow flower that is important for us here because it is an example of a very co-evolved relationship. The flower is pollinated by the yucca moth. The yucca moth rolls up some pollen, tucks it under its chin, and unlike most pollinators, which purposely rolls up some pollen, a ball of pollen, tucks it under its chin and takes it to another plant, pollinates another plant so that that plant will produce seeds, which will be the food of the larva of the yucca moth. So again, mutualism at work here. The moth pollinates the plant, helps it produce seeds, which are important to the plant, and those seeds then are used as a food source for the larva of the yucca moth. This again is also a species only found in Iowa in the Loess Hills, so endemic to the Loess Hills in Iowa. The next one I'm going to point out here is a little grass-like plant right here. We look at the grasses around here, we see a lot of little blue stem and grasses that are well adapted to the dry soil. But this is not a grass. This is a little sedge. We often think of sedges, of course, occurring in wetlands, and most species of sedges do occur in wetlands. But there are many species that can occur in very dry soils, and this is a great example. This one is called sun-loving sedge. It's out here in the sun, loves the sun, the drier weather, the drier soils. Carex inops is the current scientific name for it. Fairly inconspicuous one, but it's probably one of the most abundant plants out here in the Loess Hills. Then this taller one right here next to it is a good example of a real common sunflower in the hills here and other dry prairies. Even mesic prairies to some extent. This is rigid sunflower, formerly Helianthus rigidus, and then it name was changed to Helianthus latiflorus. Rigid sunflower. Right next to it is another late summer species like the sunflower, but in the same family, the aster family. This is aromatic aster. It's kind of distinctive in the shape of the leaves and kind of how they attach to the stems. Aromatic aster is now Symphylotrichum oblongifolium. It'll produce a really nice deep purple flower. The ray florets will be kind of a deep purple coloration, like all asters later in the summer. And then there's one more I want to show you, just a little bit. Oh, there's actually one right here, part of one. And then there's actually one that's still intact. This is prairie turnip. And what's happening here is prairie turnip is a great example of a plant that disperses itself by becoming unattached. It senesces at the base, detaches from the base of the plant, and so the top part of the plant becomes a tumble plant and will be blown around by the wind, which we have plenty of today, dispersing seeds out of the fruits as it blows around. This is prairie turnip. It has compound leaves with generally 5 leaflets in a palmately arranged shape. And there is one that that hasn't quite completely dried out. It still has the fruits right here. Here's the remains of the flowers and the beginning of the fruits. And here's some green leaves. You can see again 5 leaflets here. Fair amount of pubescence on the stem and on the undersurface of these leaves. This one has not yet senesced at the base or detached. It's still probably doing some photosynthesis here, but it too will eventually break away from the base and begin to blow around to disperse the seeds.